This is a system of equations where we have an x and a y in both equations. This is different from one we saw earlier in this section. So I'm going to first show you the Desmos calculator solution for this because I think that is much more in line with what most of you will kind of try to do. And in most cases, that is going to be the most efficient, but there is a really, really easy way to do this that I'll show you at the end. But let's do the more traditional way first. So I already took the time to enter these equations into Desmos. I would absolutely double check before I start thinking about answer because these buttons are small. It's very easy to mistype something. And if you do, the calculator doesn't know you mistyped. So you're going to get the wrong answer. So x plus 3 equals negative 2y plus 5, check. X minus 3 equals 2y plus 7, check. Now, because it's just kind of calculating and solving for us, we see that point of intersection right there. If we tap it, it's going to tell us the point, 6, negative 2. So let's write that down. Let's put it up here. 6, oh, what's going on? 6, negative 2. So that's our answer, kind of. What is the value of 2x? So many of you are going to be tempted to just say, oh, x is 6, and that is an answer choice, right? So that's our value for b, but that's a trap because they don't want x, and this is one of the ways the SAT messes with us, right? Is they know our habit is to solve for x or for y, and then they kind of change it slightly to mess with us. We can also see negative 2 is y, so that's also kind of a trap, but it's really easy. Just take your x as 6 and double it because they want 2x, so 2 times 6 is 12, and C is the answer. So notice, if we plug this into Desmos, the hardest part is just entering the equations, you know, and if we do that correctly, then it's just going to solve everything for us. We might fall into this trap of just picking x, but I'm hoping that by the time you take your actual SAT, you're not going to fall for those kind of traps because you've done enough practice to know that the SAT does that. But they also do some other cool things. Let's get rid of the calculator here. Oop. Or maybe not. Go away. There we go. Okay. A lot of times, the SAT, you know, wants to reward people who are good enough at math to recognize valid shortcuts. And so the giveaway that there might be something weird or suspicious going on here is that, yeah, why aren't they asking for x? Why are they asking for 2x, right? That's weird. Now, one of the more traditional ways to solve a system of equations is to use what's called elimination. Basically, you add the two equations together, and it does it in a way that gets rid of one of the variables, because you can't solve an equation that has two different types of variables. It's just going to produce a line or a graph or whatever. So we need to get rid of one of them. And if we do that here, what I see, right, if I added these two equations together, what's convenient is that the y's would go away, right? Negative 2y plus 2y is 0. So those would cancel out. Now if we add the rest, let's see what happens. X and x is 2x. 3 and negative 3, those are going to cancel out too. So that's just 2x on the left side. And like I said, the y's will cancel out. And then 5 and 7 is 12. Well, what do you know? We wanted 2x. And if we just add the two equations together, we get 2x. Without ever even needing to know what x is. And so, yeah, we could. It's not hard. But this is why you know, might just try some things sometimes and see how it goes. You might, with very minimal work, end up kind of getting the right answer, especially if they ask for something weird. But it doesn't always work. It's not always an available shortcut. So I don't want you overcorrecting. A lot of people see a question like this and like, oh my God, there's always these little shortcuts. And so you look at complicated, you know, SAT questions and you're hunting for that shortcut. And you spend so much time looking at it, staring at it, trying different things, looking for that shortcut, that you end up taking longer than if you just did it the more kind of like methodical, reliable way of plugging it into Desmos. So that's why I don't think either of these is better, right? Like if you think of it in the grand scheme of the SAT, neither solution here is better. Yes, adding the two equations using elimination is faster in this case, but the odds of that working every time, pretty low. And Desmos working every time, pretty high. So over the course of many, many SATs, using Desmos to solve systems of equations is a more reliable, more efficient strategy, because even if you saw this shortcut, hey, there's a chance that you mess it up, right? Maybe you do 5 plus 7 and you get 13 because you're just not thinking. I don't know. I know it's not an answer, but like, you never know what's going to pop up here as possible wrong answers. So just keep that in mind, that being clever is nice when you can see it, but if you don't see the clever solution quickly, then don't worry about it. Don't try to force it. Don't spend time trying to be clever when just being kind of like a robot and plugging into the calculator would get you the answer pretty much the same way. So hopefully that's just a good overall strategy for you. But like I said, in most cases, Desmos is going to be the way to solve systems of equations. It works every time.